Slides are visible, right?
Yes, visible.
Okay. So this is the first question, and you have 2 minutes time to answer it. Yes, too many people are responding. So here multiple options can be correct. So according to that, you answer. Yes, Subhasri. Okay. So let's discuss this one. So what was the question? Which one of the following polymerization process is or are heterogeneous? So heterogeneous means, so there are two or more phases are present, right? So answer will be 1 A, C and D. Why I am telling you? So in case of suspension polymerization, it is heterogeneous. So why it is heterogeneous? So here we used mainly monomer, that is not soluble in water. In this case, only aqueous media was used most of the cases. So monomer and the initiator are not soluble in water, right? And what happens here, the polymer that will be formed, that is also polymer that is not also soluble. Here we also use some surfactant. So what happens if in the solution, in the polymerization vial, you say this is the polymerization vial and polymerization mixture, they form this type of polymeric beads. So in this microenvironment, monomer, initiator, all the things are present, and in these beads itself contains the produced polymer as well. So in these beads actually uh, acts as a small polymeric chamber. Okay, so polymerization takes place here. So here you can say this is one phase, this is one phase. So this is not a one phase solution, so this is heterogeneous phase in case of suspension polymerization. So in solution polymerization, all the monomers and the initiator and the polymer all are actually soluble in the media. So there is no heterogeneity into the system. So all these things are homogeneous. So what is there? Monomer, initiator, and the produced polymer all are soluble in media. Okay, so that's why it is actually a homogeneous reaction. So there is no heterogeneity is there. So whoever told that B is the answer, so this is not the answer. I mean, solution for polymerization is a homogeneous polymerization, not a heterogeneous polymerization. In case of emulsion polymerization, so it is here also it is a, I mean, what I will say, I mean, it is a, I mean, polymerization technique where it is not, it is a heterogeneous polymerization technique. So in this case, the monomer is not soluble in water. Okay, and maybe it is negligibly soluble or poorly soluble, but not actually soluble. But the initiator is soluble. Okay, and the polymer that will be produced polymers are also insoluble. So what happens here also, you will find some microenvironment. So actually in this case, two types of particles will be formed. One micellar type small particles and some monomeric that chamber that will actually the monomer which are not actually soluble. So that type of big particles are present. There is a several different case that was actually taught in the class, I guess. So that is a different case, but it is actually not. So you can ask me a question, but after the class, I will. After the class, if time permits, you please ask me. Okay, let me now do this thing. Okay, and interfacial polymerization is also a, I mean, heterogeneous polymerization. In this case, what happens? Two types of solvents are used, immiscible solvents. Like in mostly it was done in step growth polymerization. Okay, for step growth polymerization. Okay, so what happens? One monomer is soluble in, let's say monomer 1 is soluble in this phase, monomer 2 is soluble in this phase, and the polymer forms here in the interface of this two layer. Okay, so this is actually heterogeneous. I mean, the solution is not a homogeneous solution. However, in the bulk polymerization case, so it is actually neat polymerization. Okay, so there is no solvent is present. So all the produced polymer and initiator are soluble in monomer. Okay, so this is the bulk polymerization. So this is also a homogeneous polymerization, because there is all whatever thing is forming, or the reagent or whatever we are using for the polymerization, that is in the same phase. I mean, there is no heterogeneity into the system. So only option A, option C, and option D, these three are the example of heterogeneous polymerization. So one question came that bulk polymerization in solution polymerization, bulk polymerization for bulk formation in solution polymerization, and this is the disadvantage of that. No, bulk polymerization is separate thing, solution polymerization is separate thing, in more or less same, but in case of solution polymerization we use the solvent. Okay, but in case of bulk polymerization we don't use the solvent. So the monomer itself acts as a solvent. So whatever initiator is present, the polymer that will be produced, that will be soluble in monomeric system, that monomer. Okay, yes, that is bulk polymerization is it has some disadvantages, but advantages are also there. Okay, so the polymer that will be produced, that will be, there is no impurity will be there. So actually, we are using some organic solvents to make the polymer. So there are some impurities are there. So that type of impurities will not be present in this case. However, disadvantage is that the reaction will be very fast. Okay, so there is no such thing is, I mean, solvent is present, so the density will be very high, so it will eventually react and form some very viscous polymeric material. So the processing of those polymers will be very difficult. Okay, so we generally do precipitation technique to purify the polymer, and that will be very difficult for to do in this case. I mean, if it forms very viscous polymer, and controlling the polymer growth is also very difficult. Yes, there are some disadvantages. So in the side, the polymer mix solvent inside the polymer make bulky nature solution polymerization facing. No, I don't understand your concern. I mean, whatever it is, I mean, I don't know what you trying to say, but whatever it is, but both the cases in solution polymerization and the bulk polymerization all are in the same phase. I mean, everything is soluble. There is no precipitation, no emulsion, no anything hazy thing is forming that is not soluble in the polymerization is not there. Okay, so if it is being difficult for you to understand, let's say in the polymerization vessel, if you found something that is actually hazy, not solubilizing in that media, maybe that is the produced polymer, maybe that is the monomer, maybe that is the initiator, whatever it is. Okay, if it is there, then it is the heterogeneous. Okay, however, if the polymer solution, all the polymer thing, monomer, initiator, all are soluble, you find a clear solution, clear thing in the polymerization vessel. It is the homogeneous polymerization. Is that okay? You understand, right? If yes, then we will go to the next thing. Next question. Okay. So this is the informative type question. So you take 1 minute to answer. Please hurry up. Only we have covered in 20 minutes. We have covered only one question. Two answers. Okay. I told the people various people are joining now also. I mean, I will not allow them to join. Okay. Now whoever trying to join, I will not allow them. This is the last one I am accepting, but I will deny their response. Yeah, most of them given the right answer. So option A is the right answer for the emulsion polymerization. This is the thing, and for your I mean notes, you can take that the for suspension polymerization. Suspension polymerization, it is around 1 to 100 micrometer, and dispersion polymerization, it is around uh, 1 to 10 micrometer. Okay, so it can be larger than that also. I mean, it can be 100 to 500 also. Okay, micrometer, it is very large amount of particle can be formed. So any doubt from here? No, right? Then let's go to the next one. Okay, many people have given the actually the right answer. So emulsion polymerization is the right answer. So you can, if you find out the rate equation of the emulsion polymerization. Anyone want to say anything? Hello, whoever it is. I mean, Shubho, what? Please mute yourself. Okay, so if you find the rate equation of this thing, I mean emulsion polymerization, it is, so what is RPP? RPP is the for the each of the particles. What is the rate? Okay, so rate of the polymerization, rate of polymerization per particle, or NP is the number of particle. per unit volume. Okay, so if you check, this is the equation for the emulsion polymerization. So RPP is equal to actually Kp MP, that is the monomer concentration, and the radical concentration, right? For each of the uh, for each of the particle I am talking about. So let's say n number of particles are present, okay, and then the density will be Na. Okay, so this is the concentration, number average concentration. So Na is the Avogadro number, and number of the radical present in per particle is n. So we can actually write it like this thing, Na. Okay. Now you have already studied that emulsion polymerization. So the particle size that is the forming in the emulsion polymer, those the particle that is emulsified in the polymeric system, the size is very small. Okay, in that small environment, either one radical is present or no other radical can be present, because when let's say one radical is present into the that micro environment, and another if the another radical comes there, then it will make a dead polymer. I mean, they will conjugate and you will make a dead polymer. So there is no monomer initiated thing is present. So either it can be 1 or it can be 2. So if we take the average, so n is equal to half, right? Sorry, n is equal to half. So what can we write? Mp by 2 Na. Okay, so we can put it here. So what will be the case? Rp is proportional to Mp, right? Okay, and for the xn also, if you know the formula, Np Kp for each of the particles. Okay, so in a Avogadro number, Kd dissociation constant by I. So I is the initiator concentration. So here also, so forget about everything. It is proportional to Mp. Okay. So in this both the cases, if we increase the polymerization can be increased. So here in this case, so if we increase the monomer concentration, both the polymer concentration, polymerization rate and the this xn value can be increased. In all the cases, what we have found previously in the free radical cases, what we found, we actually found it is actually reversible. If we increase one, if we increase the monomer concentration, then Rp will increase, but the xn will decrease. Okay, but in this case, the both the thing will increase. Okay, so anyone has in doubt? Okay, if not, then go to the next one. This is an easy one, don't take too much of time. Please read the question, Oshini. I mean, which of the following is not an example of reversible deactivation radical polymerization? They are which is not the example. Find few of them given the wrong answer. This is not acceptable actually. I mean, the right answer is this. All these three are the example of the reversible addition, reversible deactivation, radical polymerization. So this RDRP also can be denoted as controlled free radical polymerization. Okay, and all this is NMP. Here this is ATRP, and this is RAF. Okay, all these three techniques are used to control the molecular weight. So here some reagents, or you can say here this is a raft agent we use. Here in ATRP some alkyl halide and some ligands are used, and in this case some stable free radicals are used. That is actually activate. They are basically used to maintain a equilibrium, okay, between the radical state and their dormant state. Okay, so this process is reversible. It can go to the radical state, and it can the radical can be quenched as well. So I don't know. It is very difficult for me to now if we tell you the whole story. But this is the thing. This is very well known and common process. Okay, so these A, B, and C, all these are used to control the free radical polymerization. So in free radical polymerization, what happens actually? So there is no control, right? So if you initiate the polymerization process, you give the initiator, you initiated the the initiator with temperature, and the polymerization will go on, and there is no until and unless the monomer concentration goes down, the polymerization will take place. And also those are not living polymerization. So further, if you make the polymer and after that you wanted to make another polymer, you want to increase the chain length of the that polymer with another functional motif or anything, that you can do it. But in this case you can do it. Okay, so to control the molecular rate and for making a living chain end that will further polymerize in presence of AIBN and the monomer, these techniques were discovered. Okay, so one is NMP, nitro oxide mediated radical polymerization, ATRP, and RAF. Okay, so you study these things, and in this case the free radical is not it cannot be controlled, so there is no point of. So how we can control actually? If you say, let's say in the free radical polymerization the concentration of initiator is too high, so to decrease the polymerization initiator concentration, what we can do, we can make a equilibrium. Okay, so sometime that the initiator form the radical and it will go into the dormant state. Okay, so there will be a equilibrium is present. So that only possible in case of controlled polymerization techniques or the living polymerization techniques, that are NMP, ATRP, and RAF. Okay, But in case of free radical polymerization, these techniques are not present. Okay, so these are not. This is the not example of reversible deactivation radical polymerization or the living free control free radical polymerization, or this is also can be called as living polymerization, living free radical polymerization. Understood? I mean, I found many people have given the wrong answer. I don't know why. I mean, is it okay? Okay, then go to the next one. This is a small numerical type question. Try to answer it. Dibyendu, I found today you have given two wrong answer. That doesn't happen. You and Uddhay gives the right answer always. So study well. I mean, go through the study materials and the videos. Then you will understand these things. I mean, in this 1 hour, I can't go through all those things, but I generally try to cover most of the things. I mean, I take the questions in such a way that I can cover all these things, but you have to go through the videos and the study materials. I didn't get a single answer. It's a very easy one. Please try to solve it. If it is wrong, if it is also fine. I mean, try to solve it. That's why I didn't put any numerical question in this time. I mean, most of the questions are MCQ type. At least one answer I expect from you. One of you at least do the maths and tell me what is the number average molecular weight. Okay. 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 Anyone else? I mean, Samala, you don't need actually too much of mathematics to do all these things. I mean, there is no integration, no nothing is there. I mean, just little bit of I mean, division, subtraction, those basic maths are there. I mean, and whatever I take numerical problems I take, I always do it in a, I mean, I explain it well. I mean, if it is difficult for you also, then I can do it. I mean, there is no problem of that. But actually try to understand on your own first, then if it is also it is not clear, then you ask me. Okay. So you those things, those these whatever I am teaching, these things are available in YouTube also. I mean, if you find if you I mean, type my name in YouTube, you will find these lectures as well. So from there, if you find something you couldn't understand here, you can go there and again you can recheck. Okay. uh, and believe me, though, these are very easy thing. I mean, you don't need to have any mathematical background to do all these things. I mean, you try first, and there is also solvable, I mean, solved materials are there also. They also provide the how to solve it. You I'm sure you will be able to do it. I mean, if it is not there, then I am here. Don't worry. But first you try, then I will tell you. Okay. So another answer I got from Uddhar. So let's actually discuss this. I mean, Dipendu, your answer is wrong. Okay. So this is not the 50,000, but yeah, Uddhar's answer is right. So I am telling you how to do it. I mean, anyway, it's fine if you do it wrong. It's not a big deal. So Mn is, what is the Mn value? So Xn into M0. Okay, so Xn is the degree of polymerization, right? So degree of polymerization, M0 is the molecular weight of the monomer. Okay, so what is the molecular weight for of styrene? So here only styrene is there. Yeah, styrene. So styrene, your molecular weight is 104. Okay. So how now we know these things, and we have to calculate this Xn value. Okay, right? So the styrene concentration is 0.1 molar, and the CTA, I mean the chain transfer agent or the wrapped agent, that actually controls the molecular weight of the polymer, that the concentration of CTA is 0.001 molar. Okay, so what is the CTA? I mean, let's say we are taking, let's say in equivalent weight. Okay, so we are taking styrene equivalent 10 and CTA equivalent 1. Okay, that means in one chain 10 styrene is there. Okay, 10 styrene motif should be present theoretically. Okay, likewise 10 should be present. So here the concentration is 0.1 and here the concentration is 0.001. So let's divide it 0.1 by 0.001. So this is 100. So what is the thing? Monomer by CTA ratio is 100. That means here in this case what they have taken, 100 unit of 100 equivalent of styrene and 1 equivalent of CTA. Okay, so that means in this case in one chain like this way 100 styrene motif should be present. However, the polymer, if you find the conversion, that is only 80%. That means among these 100 only 80% was consumed. So 100 into 0.8. Okay, so you got this thing, and so this is actually your xn value. So this is the xn value. Okay, so this is 80. Okay, so if you do 80 into 104, so this is 0. So 8320. So this is our answer, 8320. So you didn't complete your videos. That is not, I can't do it anything. Okay, I have to take the class in Friday from 7, whether you finish your videos or not. Okay, I have to, and you are also bound to do, do the study, and you should go through all these things. Okay, anyway, it is a discussion type class. You will have time to further, I will suggest you to go through your study material videos first and then come to the this video. You will have, it is available in YouTube. You go to YouTube, you again try to solve it, then it will be very, very much beneficial for you. Okay, let's go to the next one. Hurry up. So compared to free radical polymerization, the ionic polymerization are generally conducted at, you have to tell what is the solvent nature and what is the temperature compared to free radical polymerization. Okay. One answer. Try to answer. This is a MCQ question. You should at least guess. If you didn't finish the video, at least guess what could be the answer. No. Shamala, I can't take that thing. That is not my, that is not in my hand. Okay, so my job is to do take this type of discussion type class for 1 hour from Friday 7 to 8. I mean that I can take till 7 to 8, 8:15 or 8:30. That much I can do, but after that it is not possible, because you find there I mean, the student who are doing this course is very large. I mean, then we have to I have to talk with NPTL. Then they will generate another I mean, this type of meeting link. Then it will be conducted, and this will be a huge problem. Okay, so there are also a feedback thing or any discussion forum is there also in the NPTL course. I don't know, I mean it should be there. So you can write there also, and there is also some TAs who actually take care of this thing. They actually, I mean, uh, recheck your assignments, all those things they do. Okay, so you can communicate with them also. Okay, they can tell you, but our job, actually my job, actually we are the PMRF fellows, so our job is to take 1 hour type class, discuss with you, I mean this assignment problems and how to solve it, and any gap, anything, that is our job. Okay, I'm sorry to say, but I can't do it. Okay, I mean, don't take it otherwise, but I can't do it. Okay, let's try to answer it. So this is the C is the right answer. Okay, why C is the right answer? So you take any it is called, it was written that ionic polymerization. Okay, so I now one person is trying to join, I mean it's terrific. So let's say this is the monomer, and you can initiate with this or like this. Okay, so in this case it will initiate, and and it will form like uh, this type of thing, and if this initiates, then it can form plus, right? So in both the cases you can find these, and for this and this both are polar, right? Polar, because there is some charges present. Yes, there will be some counter anion or counter cation to balance this charge, but overall this is actually both are polar. Okay, so to stabilize the polar I mean intermediate, we need a polar solvent, right? We need a, so intermediate is polar. So we need polar solvent. But if the solvent is too much polar, so if it will stabilize it, right? If it this intermediate got stabilized, very much stabilized, then it will, the polymerization will decrease. Because it will not be able to, I mean, react with the other monomer, because it is already much more stable, so it can't actually react with the other monomer. So we need a polar solvent, but it have to be moderately polar, right? So we need moderately polar solvent to carry out this anionic polymerization process. And here in this case also you find out this type of, in the carbon atom, one either positive charge or positive negative charge is present. Maybe this can be stabilized by this R group, but this type of species is present. So these are very reactive, right? So if you increase the temperature, the reactivity will also increases. Okay, or otherwise it will quench or anything will happen, but these species will not remain in this way. So to I mean to maintain this thing, we need actually lower temperature also, right? So for this ionic polymerization, what we need? Moderately polar solvent and lower temperature. Okay, any confusion? If not, then go to the next one. Hurry up, hurry up. Very easy one. This is a very easy one. I only got 2 answer, 3 answer. Now everyone is getting back to the form. Great. Everyone is given the right answer. I mean, I know most of the people don't. I mean, are join this class, but don't actually get involved into these things. But whoever given the answer is the right answer. One answer is correct. I mean, Valley. I found this is not the B. It is actually reverse one. I mean the D is the right answer. So why it is the right answer? You know, if you find out the intermediate, this is this type of intermediate there, this octahedral type moiety. So what happens? This type of compound, let's say X. Okay, so this actually goes into this and form this chain propagate, and after that, so this this monomers goes into this unit. Okay, so if the steric hindrance is too high, then it will be very difficult to accommodate there, right, in the axial position, right? So if the steric hindrance is less, then only the polymerization is very much feasible. So what is the question here? What will be the order of reactivity of these 4 monomers in Ziegler-Natta polymerization? So the Ziegler-Natta polymerization, I know there is a lecture is there, so go through that. So you find out that in this case steric hindrance is least. Okay, only CH3 group was there. If it is CH2, then it is no steric hindrance at all. Okay, only CH3 group, a little bit of steric hindrance is there. So 4 highest. Okay, then 3, yes, CH2 CH3 ethyl group. So again it increase, reactivity decreases little bit, but higher. Okay, but in this case this is CH Me, and this is CH like this. So here the steric hindrance is highest, here little bit less. So 1, then and then 2. Here in this case the steric hindrance is too high, right? So the formation will be D. D is the right answer. Any confusion? Okay, go to the next one. Yes, option B is the right answer. Okay, so you just count out how many centers is there. Okay, if you write it in this way, you just count the. You can understand that this type of polymer only can be made with uh, this type of, let's say, this type of polymer can be made with ring opening polymerization, right? So in the ring, so this thing will be the, this much point will be the there. Okay, so one, one, two, three, 4, 5. So it have to be 5-member ring, right? So it have to be 5-member ring. So if take, this is a position 1. Okay, so you give oxygen here, so there is CH2 CH2, let's CH2 CH2 here, then oxygen, so then there is oxygen, another oxygen, then CH2, then CH2, like that. This is very easy. So the monomer will be the cyclic monomer will be this one. Okay, do you have any confusion? No. Okay, so this is the last question. Try to answer it. First answer this one. This one, first answer. So they are given R1 value and R2 value. So what is R1? R1 is the K11 by K212, and for R2 is the K22 by K21. Okay, so what is K11? Let's say this is the propagating radical. Let's say this is the propagating radical. This is P. Okay, so sorry. So this is P, and plus if it forms P, and if it reacts with the another P, so this will be the K11, and if it is it reacts with a Q, then it is K12. And let's say if it is Q radical, and if it is reacting with this, then K21, and if it is Q reacting with Q, then it is the reaction rate constant is K22. Okay, so ratio of K22 by K21 is R1, ratio of K11 by K12 is the R1. This is R2 and this is the R1. So what is it implies? K11 means a propagating radical, how much it want to react with its monomer. Let's say P, how the chances is there that they will react with another P. Okay, and K12 means that P is how they, what is the proportion, the possibility that it will react with Q, and for Q is also the same. So Q is how much possibility is there that P will react with Q. Okay, and further propagation will take place. Okay, so first, in which case the polymer copolymer in which case copolymer composition will be same as feed composition. So polymer will be same as feed composition means it will be 1:1. Okay, both the monomer and P and Q ratio will be 1:1. So it will be this one actually. Okay, where R1 is equal to K11 K12, that is actually 1, and R2 is equal to K22 by K21 is equal to 1. That means K11 is equal to K12 and K22 is equal to K21. So it doesn't matter actually. So P the possibility of reactivity P towards another P P radical to P monomer and the P radical to Q monomer is same. So the feed ratio will be same. I mean, you say that, I mean, if you in your +2 standard, you would have done that if you toss a coin for infinite number of time, okay, so what will be the chance of getting head, or what will be the chance of getting tail? So that will be 0.5, right? 50% should be the case. I mean, if it is not biased, I mean that coin is unbiased, then always the chance is 50-50. I mean, it can get 50% of head and 50% of tail if you do the infinite time, if you toss it. Here also in the case is same. So the possibility of P radical, this one is reacting with P and reacting with Q are same. Okay, so this is the theoretical thing. I mean, I'm not telling that always this will happen. Okay, maybe in 1:1 you can get the 1.1:1 or 1.05:1. That can be the case. Okay, always 1:1, that doesn't happen in this way. But idea was this thing. Okay, if if you see that it can, the reactivity towards this with this and this with this are same, and here also this with this and this with this are same, so it can go anywhere. Okay, and it can propagate in any direction. So there is the always the chance is that it will have a same feed composition. Okay, anyone have any doubt or anything? So please solve the last one. The mole fraction of the P in the product of 3. So in this case, yes, Uddar.
Sir, if R1 equal to 1, R2 equal to 1, then there will be equal probability for both the monomer to add, sir. Then
Yes.
It will be random copolymer.
Yes, it will be random copolymer. But we are talking that after completion of the polymerization, so let's say 0.1 milli, if the 0.1 millimole or mole P is present in one chain, then 0.1 mole Q will be present. But the distribution will be random. Distribution is random.
Okay, sir.
Okay. Anyone got the answer? Okay, let me answer it. So what they have told that R1 is equal to 0 and R2 is equal to 0. Let me tell you, in the actual case, in the actual scenario, in practically, it cannot be the case. Okay, the reactivity is 0 means it cannot react. Okay, that should not happen. Theoretically it is possible, but practically it is not possible. So R1, I told you, it means K11 by K12. This is 0. That means K11 is 0. Okay, and KR2 is also 0. So K22 by K21 is equal to 0. So K22 is equal to 0. So what it means? It means actually that P radical, this reaction with P itself is not possible. So their reactivity is very slow, but it can react with the Q. Okay, let's say it formed actually P, here P and here Q. Now Q again cannot react with another Q. Okay, because this will be the K22, and you can see that K22 is equal to 0. so it cannot react with K22. Okay, so it have to react with the another P radical. So what will happen? P, Q, and again P, and again one Q will be in the chain. So it will be like PQ, 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 like this way. So this is alternating copolymer. Okay, so this will be the alternating copolymer. And in alternating copolymer, what is the mole fraction? I told you. I mean, if 0.1% is there, here also will be 0.1. Okay, so the mole fraction will be 0.5. I mean, 50% P will be there, or 50% and 50% Q will be there. So if you find it in mole fraction, it will be 0.5. So anyone have any doubt?
Sir, then this one also will have same feed composition.
Yeah, it is a feed composition is okay. You are telling that the okay, they are all only they asked for the feed composition, right?
Yes, sir.
Okay, okay, okay. Yeah, in this case 2 and 3 both are correct in the in this case. Okay, in this case 2 and 3 both are correct. Okay,
Sir,
but in
then
this
fourth one.
4 is not correct, right? 4 is the this reaction, this is too much high. Okay, this I mean K22 is high. I mean they have high. I mean if this type of chain is present, then the high chances it is react with the another Q. Okay, so this is not this cannot be the case. Okay, but in this case the here it will be the random here, but here it will be the alternating copolymer. Okay, anyone have any doubt? If not, then thank you. That was the last question. Okay, so I am stopping the presentation and good night. We will see you in the next Friday from 7. Yeah, sorry. Here some one person was there, Aman, right? You have a question. You had a question. You told that you asked for any some recent from assignment from I mean question from recent assignment. I don't know the recent assignment what was there, but you give me the answer. You give me the question. I will try to answer it. It is already 1 hour. Is there? We have finished 1 hour. So I will discuss in the next class. If Aman is present, I don't know Aman is present or not. His name was Aman, right? Yes, Aman Singh. Yes, Tamil Mozi raised your hand. You raised your hand. So, if you have any question, okay. Okay. Good night. Yeah, you can send me if you have any question through email. I will next session I will give you. I mean, I will try to. I will give it to the everyone. If they can't solve it, we will solve it together. But don't. I mean, give the recent, very recent assignments problem. Okay, then it is, we should not do that actually. I mean, it's not our authority to solve it, because that was for you to solve it. Okay, good night.